Now, to solve this problem, how and from where will you begin? You can begin from two places. Either you can go or start to think of A, or you can, what can you do? Or you can start to think of F and G. Because the molecular formula of A is given, so it's better to start from A and think of the possible structures of A. And there's a hint here that on ozonolysis of D, you're getting E. Generally on ozonolysis, there will be a lysis, there will be a breakdown of alkene, and you'll have two halves. So there will be two molecules. But because only one product has been shown, that means both the part after ozonolysis are same, and that is E. So the hint is that D is a symmetrical alkene. So let's start from here. D is a symmetrical alkene, and we know the molecular formula of D because D has been given as isomer of A, and isomers have same molecular formulas, right? So the molecular formula of D is also C6H12. So we know the molecular formula, and C6H12, that means there is one unsaturation. The degree of unsaturation is 1. So D has one alkene, we are assuming. So think of a symmetrical alkene of having 6 carbon, and that will give you the structure of D. Keeping in mind, it doesn't give Fehling solution test, and it does give iodoform test. Now let's start to draw the symmetrical structure of alkene having 6 carbon. So one obvious choice would be this. This has 6 carbon, 3 and 3, and this is symmetrical. But the problem is, when you carry out ozonolysis, you will get from this side a aldehyde, and from right hand side this aldehyde, propanol from both sides. And the problem with propanol is it gives Fehling solution, and it does not give tolerance test, iodoform test. So it's contrary to the given information. So this symmetrical structure is not valid because it doesn't give iodoform test, and it gives Fehling solutions test. So think of other structure, keeping in mind that iodoform test is given by this compound E. So E gives iodoform test. Fine. Now D has 6 carbon, so E must be having 3 carbon after ozonolysis, and E gives iodoform test. Now iodoform test is given by compounds having this group. Fine. So 2 carbons here, and E has 3 carbon because D has 6 carbon, and it will be symmetrically broken. So E has 3 carbon, and the only choice to add the 3rd carbon is on this carbon. So E must be nothing but acetone. This we have found. And once we have found E, we can very easily find D. So now for D, you have to trace back the mechanism of ozonolysis. You have to merge 2 molecules of E, and then you will get D. So if you are going to merge 2 molecules of E, these are the 2 molecules of E. Now what you have to do is you have to merge these 2 C double bond O, as we did lots of practice during ozonolysis reaction. This is what D must be. Look, it has 6 carbon, it has 1 degree of unsaturation. The molecular formula is C6H12. Fine. So that's the first success. We have found out D. Now next what you have to do is, now we have found out D and we have found out E. E is acetone, and D is this given compound. So D has been found out. Next you have to find B. Now B, what can be B? Okay. Now B has a chlorine, and after elimination you are getting D. So what the possibilities are that this chlorine can be at this position. This chlorine has to be at this position, because if the chlorine is at any other position, suppose chlorine is at this position, then the base will abstract, suppose chlorine is at this position, then the base will abstract hydrogen from here and an alkene will be formed at this position. Fine. So this is not the desired alkene. We want the position of alkene to be here. If the position of alkene is to be here, then chlorine has to be either on this carbon or on this carbon. So it's symmetrical. Let's take on any carbon. Fine. So this is what should be B. B is this. Fine. then only the alkene will come at this position as the structure we have identified, that of D. So we have found out E, D, and this compound is B. Now there's little space on the board, so I'll keep on rubbing this and I'll be adding different compounds. So you keep on noting the compound. This particular compound is B. Now you have identified B. Now you have to go for identification of A. Fine. Now methyl, this chlorine has been attached here, and A must be a alkene. So the position of alkene, one can be at this position. The position of alkene can be at this position. These are the two possible positions of alkene on which if HCl is added, then chlorine will come at this position. Suppose alkene is here, then H will be added here and Cl will be added here. Fine. In the compound B, this will be CS3. H will be added here, Cl will be added here. Suppose alkene is at this position, then H will be added here and Cl will be added here. So alkene can be at any two positions if we consider this particular structure. But the problem with this structure is, as per this information, when you carry out ozonolysis on A, then you get F and you get G. And then when you carry on Cannizzaro reaction of F and G, you are getting sodium salt of formic acid. Now, if you know Cannizzaro reaction, and you have to know because I have taught you, as per Cannizzaro reaction, the only way to get this sodium salt of formic acid is when you start with formaldehyde. If you don't start with formaldehyde, there is no way you can get sodium salt of formic acid. So out of either one of them, one of F and G has to be formic acid. Fine. So this position is ruled out because alkene, if is at this position in A, then when you carry out ozonolysis on A, you get acetone from both the sides. And you don't have, that means F and G both will be acetones. So, but out of one of F and G, it has to be formaldehyde. So, if alkene is at this position, formaldehyde won't come out after ozonolysis. So, this position is ruled out. Alkene cannot be at this position. Let's see at this position. When you have alkene at this position, then if you carry out ozonolysis, this right hand part having one carbon will come out as formaldehyde, and that's what we require. So this can be an option, right? But we have to check other things. The other thing is, this is a primary alcohol. The reduced product of this is a primary alcohol. Now, if you take F and G, suppose G is formaldehyde, one of them has to be formaldehyde because you are getting sodium salt of formic acid. So if G is formaldehyde, F has to be a such aldehyde that after reduction it gives a primary alcohol. Now primary alcohol, suppose you have benzaldehyde. Then if you reduce it, if you add a hydrogen like this, OH and H, then it is a primary alcohol. Now if you have a ketone, suppose if you have acetone, if you have a ketone, then that will never be a primary alcohol. That will always be a secondary alcohol, or that will always be a secondary alcohol if you have a ketone. Now because it's a primary alcohol, then F is a aldehyde, and since it's a Cannizzaro reaction, both has to be aldehyde. Now F is a aldehyde. If you consider this structure, then from right hand side, of course you are getting formaldehyde, but from left hand side you are getting a ketone. Fine, because look, this carbon is attached with two other carbons, so this is a ketone. This will not be a aldehyde. So this structure is not possible for A to have these reactions. That means A cannot have this basic structure. A has to have some other structure, and this is a challenge, and this is a very good problem. You have to think of A, what A can be. Now after due thinking, I'm sure you will come to your answer, and you will have a structure something like this. Now if you, first of all, to check, this is C6H12, right? Next thing to check, if you do ozonolysis as per this reaction, you're going to get two aldehydes. From the right hand side, you're going to get formaldehyde as is demanded for the formation of sodium salt of formic acid, and from the left hand side also you're going to get a aldehyde. And if you're going to get an aldehyde, then after Cannizzaro reaction you will have a primary alcohol as the information given. So this structure fulfills all the demands. Now let's check. Now I'm writing down the answer once again.